In this video, we will practice solving triangles using the law of sines and the ambiguous case. Now, the ambiguous case is when you are given the side-side angle set of information, two sides and the non-included angle. They call it the ambiguous case because we don't know if it's going to form one triangle, two triangles, or maybe even no triangles at all. So anytime you see two sides and an angle given, here's what I want you to do. Go ahead and draw a diagram. All right, set up your triangle with a horizontal line. On the left-hand side, build your angle. Okay, so this will be the angle in this case. So there's 30 degrees. That makes this angle A. Now on this side, we're going to treat this like it's a hinge. And so this is going to be my swing side. We're going to imagine that this could swing from left to right on this hinge. And I'm making it dotted because we don't know if it'll really be there or not. But if this is angle A, that means this is side A. So that's why I'm going to put the 7 here, because that's A. Now, let your other side be the rigid side. Rigid means non-moving. And this side is rigid, it will not move. So I'm going to put the 6 here. That means this is side B, which means that this is angle B, which means that this must be angle C. So before we go solving this triangle, the first thing we have to do is decide if this information can even make a triangle in the first place. So the way we can figure that out is we need to check the height of the triangle. Okay, I'm going to call this H. We can calculate the height from the sine. If I do the sine of angle 30, that's going to equal opposite over hypotenuse. So that's going to be H over 6. If I multiply by 6 on both sides, that's going to give me 6 sine 30 is equal to H. Now normally I would put this in my calculator, but sine of 30, just like the sine of pi over 6, this is one of those values that we should have memorized. So the sine of 30 degrees is 1/2. So that means this is 6 times 1/2. So this is going to be 3. So the height is 3. But if you forgot that, you could have put this in your calculator as well. Anyway, the height is 3. So, will this information form a triangle? The answer is yes, because the swing side is 7. That's longer than 3, so it will definitely reach the other side. So then the only question is, will it form two triangles? Well, the way you could possibly form two triangles is if we swung the swing side to the inside, like this. If that would make another triangle, then we'll have two triangles. So that would make the 7 be right here. But this will not work because this is longer than the rigid side. Okay, the rigid side is 6, and now the swing side is 7. This is longer, so it's going to stretch outside of the triangle. It will not fit inside because it's longer than 6. So this will not make another triangle. So that means we're just going to have the one triangle that I drew in blue. So maybe I'll erase some of this. Okay, so we're just going to have the one triangle. With that in mind, we can go ahead and solve this triangle. Okay, so the three pieces of information that we're going to need. We are missing angle B, so we're going to have to find the measure of angle B. We are missing angle C. And we are missing side C. So to solve the triangle, we will have to find these three pieces of information. So let's go ahead and use the law of sines. So we have an angle and its opposite side. So I can say sine of 30 over 7. And now I can do, for example, I can find angle B by saying the sine of angle B over 6. So I need to get this sine of B by itself. I can do that by multiplying both sides by 6. That way the 6's will cancel out, and now I have the sine of B. Now if I want to find angle B, I need to do the inverse sine. So I'm going to do the inverse sine of all of this. And that should give me the measure of angle B. So I'm just going to put all of this in my calculator. So I got, for angle B, I got 25, I'll put it here first, 25.377. Okay, once I have these two angles, I can quickly find the third by subtracting these two from 180. So that's giving me 124.623. For angle C. Now, side C is down here, and I can do the law of sines again to find it. So I will just do that over here. So I think this time I will do the reciprocal way of doing it. So I'm going to do 7 over sine 30. All right, same ratio as before, but I'm doing it upside down. So 7 over 30 will equal, so that'll be C over the sine of 124.623. Okay, if I want to get C by itself, what I have to do is multiply by sine 124.623 on both sides. Okay, so over here these will cancel each other out, and that will give me C. So I'm just going to put all this in my calculator. So that's giving me that C is 11.521. And that's it for number 1. All right, let's go ahead and do problem number 2. Okay, again, as soon as I see that we are given two sides and an angle, this might be the ambiguous case. So I'm immediately going to draw my triangle like this. I'm going to put my angle on the left-hand side with a hinge, and I'm going to put my swing side dotted right here. So my one angle, I will put it on the left side. All right, if this is angle B, then this is side B, so this will be 15. Put the other side as your rigid side, so I'll put the 25 here. Since this is side A, that means this must be angle A, therefore this must be angle C. Next, I need to make sure that this will form a triangle at all. And to do that, I need to check the height. So if I do sine of 85, so sine of 85, that should equal opposite over hypotenuse. So h over 25. Multiplying both sides by 25 gives me 25 sine 85 is equal to the height. I'm just going to put this in my calculator. And I am getting 24.905 for the height. Well, that is very, very interesting. Okay, if my height is 24, and I'm just going to round this to 24.9 because that's going to be enough for me to make my point. The question is, will the swing side reach to the other side? And the answer is going to be no. The swing side is not going to reach because the swing side is only length 15. The height of the triangle is almost 25. So this is much longer. So 15 is too short. Even if I stretched it straight down, all right, 15 is not going to reach if the height is 24.9. So this will not form a triangle. So we will write no solution. And we'll move on to the next problem. So for problem number 3, again, we're given two sides and an angle. So this is probably going to be the ambiguous case. So I'm going to go ahead and set up my triangle with a horizontal line and an angle on the left. And here is my swing side. So I've always put the angle here on the left. So this is angle A. That means this must be side A. So that's why I'm going to put the 4 here. Now the other side needs to be your rigid side. So I'm going to put the 3 there. If this is B, that means this is angle B. So this must be angle C. Before I go any further, I need to make sure that this is going to make a triangle at all. So to see if this is going to make a triangle at all, I need to check the height. Okay, let's find the height. So look, the sine of 40 is going to equal opposite over hypotenuse. So that's h over 3. If I multiply both sides by 3, that's going to give me 3 sine 40 is equal to the height. I'm just going to punch this in my calculator real quick. So that's giving me the height is equal to 1.928. Okay, so the height is approximately 1.9. So, will this make a triangle? Will the swing side reach and form a triangle? Well, yes, it will. The swing side is length 4. That's much longer than the height. So it will definitely reach to the other side and form a triangle. So the only question is, will it form two triangles? And the way we sometimes get two triangles is if we take the swing side and we swing it inward. Okay, if we take the swing side and we swing it inside the triangle like this, then if this is possible, then that will form a second skinnier triangle right here. So that would mean that this would be 4, right? Because we just swung it. But this is not possible because the swing side is longer than the rigid side. So it won't fit in here. All right? It would stretch out. It would come outside of the triangle. So because the swing side does not fit, that means we only have one triangle that can be formed. Okay, so I'm just going to write one triangle. Okay, and now let's go ahead and solve this one triangle. Okay, so I guess I won't be needing any of this really. Oops. Okay. Law of sines. So I can do this. Sine of 40 over 4 is going to equal the sine of angle B over 3. If I multiply both sides by 3, then these are going to cancel each other out. So now I have sine B. But I don't want sine B, I want just angle B. If you want the angle out of this, you need to do the inverse sine. So the inverse sine of 3 sine 40 over 4. That should give me angle B. So I'm just going to put this whole thing in my calculator. So I am getting 28.822, and that's going to be B. Well, you know what? I forgot to write down the pieces of information that I'm actually looking for. So let me stop and do that now. I am missing angle B, so we were going to have to find the measure of angle B, which did turn out to be 28.822. I will also need to find the measure of angle C, and I will need to find side C. Alright, so in the end, I'm going to need all three of these pieces of information. I can find the measure of angle C right now because the sum of these angles should be 180. So I'm just going to subtract both of these from 180. That's going to be 111.178. Okay, now I need to find side C. Well, we can start off with this ratio again. I think just for fun, I'm going to do it the reciprocal way this time. So instead of doing the sine of the angle over the side, I'm going to do the side, put a little line here, I'm going to do the side over the sine of the angle. Okay, now I'm looking for side C, so that's going to be C over the sine of 111.178. So I can easily get C by itself by multiplying by sine 111.178. These will cancel each other out and leave me with C. So I'm just going to put all of this in my calculator. So that gave me 5.803. So that's it for problem number 3. Alright, this video is getting a little bit long, but I'm going to go ahead and squeeze one more problem in. Again, I see that we have two sides and an angle. So this is probably going to be the ambiguous case. So I am going to go ahead and set it up like this. Anytime I see two sides and an angle, go ahead and draw your angle to the left-hand side. And then draw yourself a swing side like that. So if this is my angle is 180 and 5. Well, you know what? This is an obtuse angle, so I probably shouldn't draw it as though it were acute, because that's going to mess up certain things. It's going to make it hard to see certain things. So I need to go ahead and draw this as an obtuse angle this time. Okay, so this is going to be an obtuse angle like this. Okay, and so here is going to be my other side. So this is going to be my 105. So this is angle A. That means this must be side A, which is 12. And so this will be my rigid side, which will be 15. Since the 15 is side B, that means this is angle B over here, and this must be angle C. Before I go solving any triangles, I need to ask myself, would this form a triangle at all? Remember, we made this a dotted line because we don't know if this would actually reach. We have to think about it. Would it? And the answer is no. This is not going to reach. It's not going to form a triangle because look at the length of the rigid side. This is 15. Now look at the length of the swing side. This is 12. This is far too short. Imagine swinging our swing side back and forth like this. Okay, imagine we're swinging our swing side. When it comes close to the rigid side, you see that it's going to hit here because it's only 12. It's not going to reach past the 15. So there's no way it's going to reach all the way down here somewhere, anywhere, to reach the other side. It needed to be longer than the rigid side to reach. So this is not going to make any triangles, so this is going to be no solution.